Zero B.
So continued again. So we were talking about the applications of clustering methods. So clustering methods are normally used in the different sectors. Okay, so here one land cover image is given. Some of the land patterns are there, like some unknown patterns are there, some known patterns are there, some similar patterns are there. According to the similarity, one can group the particular contents. Okay, so in this case, the particular clustering methods can be used. So according to the current scenario, some famous method like a k-means clustering, then ISO data clustering, fuzzy sequence clustering, and other clustering methods are there. WEKA supports k-means and other clustering methods. We will see in a practical session. So even though see this below images. So for example, surface temperature we want to calculate. So in that case, also clustering methods, even though for checking the similar newses, in this case also we can apply the filtering methods, clustering methods. Okay. Application is a market segmentation. So whatever market scenario is there, if someone wants to group market and someone wants to segment the market, so this particular clustering method can be suitable. Then you can see here second application, document clustering. Here also we can have the particular method to group the particular document. Even though email, similar emails also we can group it, right? And as per the requirement, some applications, some information we can categorize. Fine. Then second one is that association rule. Some rules based on given set of records with some number of items which are given. So according to that, we can apply some rules and we can get some output. So dependency rules which can be used in predicting the similar type of occurrences, and then based on the association between the occurrences, we can discover some associations. Okay, so association rules are used in this scenario. I'm just quickly giving the overview because we are lagging by time. So I will focus more practical now. Market-based analysis, then telecommunication alarm diagnosis, medical informatics. So in these cases, the association rules can be applied. Okay, so for sale promotion, self management, inventory management in market basket analysis. Okay, then medical informatics like disease identification and certain disease grouping association. So in that case, these methods are applied. Even though in other suspect pattern lung cancer data set, to detect the pattern, similar patterns, we can apply the association rules. Okay, so that is the scenario about this one. Fine. Now I'm just moving toward the practicals. Okay. So even though in anomaly detection also we can apply the particular grouping association algorithms. Okay, now just open the WEKA as required. So this is the WEKA Explorer, right? Then try to open the Explorer. Hope now I am clearly audible and my screen is visible. Okay, I have just opened the WEKA. Fine, and now I will try to open some files. So before opening the files, let me tell you about the clustering, whatever available in the WEKA. So just visit this cluster, but see now the option is not visible because the data is not loaded. So remember that for numerical calculations and for similar type of other calculation, the clustering methods are used. Okay, so open the file first of all, which is there in the C drive. Okay, and again open the C drive, program files, then WEKA data folder and the data. So here I'm applying some numeric data, or for example iris data, same data I'm following here, or you can have the airline data. Okay, so we will try to group some similar patterns. Okay, because clustering, as discussed, that whatever similar patterns are there, according to the similar patterns, we can group it, and then we can uh, use the particular algorithm. So I'm just opening it. Only two attributes are there, and 144 instances are there. Fine. You can see here the type of data is date type, and one of the information is a numeric type. Fine. So with respect to this, I will try to open algorithms first of all. So here under this cluster menu, just visit the clusterer. So under this choose, you can just click a choose and see some clusters like hierarchical cluster, filtered cluster, first cluster, EM, cobweb cluster. So these methods are there. Okay. And some methods are invisible. That means for this data, the canopy based method or the make density based cluster, a simple k-means, is not suitable. So k-means clustering algorithm is a famous algorithm based on Euclidean distance or Manhattan distance. Either any one of the distance algorithm we can apply here, and then we can group the similar patterns. Okay. So for this purpose, I will just open one more file, and on that file we will apply the algorithm. So like, again, I'm trying to open the iris file. So here you can see numerical values are there in all attributes. Fine. And last one is having nominal. So cluster I'm applying as it is. For example, here you can see now the remaining algorithms are clearly visible. Like a canopy was not visible when we selected the other data. Then the k-means and last two algorithms were also not visible. Fine. So in this case, we can have the particular option. So select any one of the suitable option first of all. So I am trying to apply the k-means clustering algorithm, right? Then based on this k-means clustering, just use the cluster mode. Cluster mode are having four different cluster mode, like a similar like yesterday's test set. Here also we can use the training set, supplied test sets, percentage split, but the famous method is classes to clusters evaluation. So whatever classes are there in the data, accordingly we can try to clusters, and then here whatever attributes you want to ignore. So let's consider if you want to eliminate some of the attributes. So we can just eliminate those attributes. Fine. And then here you can see select or deselect it, and it will be ignored. So right now I'm not eliminating any attribute. Fine. So in this case, just click on the k-means clustering here in this particular panel. Click on here and we will get a new window, that is a GUI of the algorithm. Here some important information we need to change. You can see canopy maximum number canopies to hold memory is 100. So cluster data using k-means algorithm. Then the minimum canopy density is 2.0. The periodic pruning rate is 1000. Canopy T1 is a minus 1.25, and canopy T2 is minus 1. Fine. Here you can see the distance function algorithm. Okay, as mentioned that Euclidean distance or Manhattan distance can be applied to the k-means clustering, but WEKA is supporting other algorithms also to find out the minimum distances between the clusters, minimum distances between the patterns. Fine. Now keep as it is the Euclidean distance, because it also calculate the minimum distances, and it gives the good result. Now here number of clusters are important. How many clusters you want to generate, how many groups we want to generate, accordingly the number of clusters can be used. Okay, now here I am just giving 3 clusters because we want 3, and in the classes also we are having 3 major attributes, 3 major classes. So that is why a number of clusters I am giving 3. Seed keep as it is, that is 10. Only one change I have done regarding the clusters. The rest of the things are as it is. Don't change the other settings. Okay, only number of clusters we can change. Or if you want to change the distance algorithm, distance based algorithm, so that we can change from this particular option. But Euclidean distance is giving the good performance, that is why keep as it is. Click OK, right? And then now just try to generate the output. Start it. After clicking start, the algorithm has started to run, and now you can see the outputs. Same iris data I have followed, and instances as no 150 instances, 5 attributes are there, and test method mode we have selected, that is classes to the cluster. So for that purpose, this first particular class we have selected. Okay, we can select other also, but for this moment we have selected the class attribute, and then we are trying to like find out the outputs. So number of instances, iterations, repetitions to perform the algorithm is a 6 here. Okay, and clusters have been 3. So initial starting points random was selected, and the error is near about 6.99. Cluster 0, 1, 2, because there we set the 3 clusters. Fine. 3 clusters we have selected there. That is why it has given again answer with the 3 clusters. Final cluster centroids 0, 1, 2. You can see here based on the pool data. So values have been generated. For 0 cluster 61 values have been generated. For 1 it is 50 and 39, and the rest of the class specific values are also generated. So for evaluating the model, we have chosen the class attribute. So according to the first class, 61 attributes are correctly classified, right? So that is our first class. You can see the iris setosa. Second, have selected the 50 attributes. Sorry, first have selected the 50 attributes and second have selected the 39. So according to the classes, first is iris versicolor and second one is the Vergenica. And you can see the classes assigned to the cluster. So 0 is nothing but this first one, iris setosa, then the versicolor and the Vergenica. So these are the categories, and incorrectly instances are 11%. So that is the output of K-means clustering algorithm. So here, according to the given input, according to the given values, 3 clusters have been generated with a near about 11% incorrect clusters. Okay, so only 11%. That means 89% correctly cluster instances are present in this particular data. Fine. Now here I will try to apply the other algorithm, for example cobweb. So check the settings. I am putting the setting as it is, then running the model. Now you can see the cobweb algorithm has given some output clustering model with a full training set 0 0. So number of marks are 0, splits are 0, and number of clusters are 3. 3 clusters have been generated according to the class, and instances are as usual. Total 150 instances are there. So those instances have been given. Okay, then you can see the assign value to the cluster 1 and 2, only 1 and 2. So first one is ignored, and the accuracy error you can see it is 33%. Okay, so this is the particular clustering about the data sets, given data sets. One more data we will try to add. So for example here I am just using this weather data. Okay, then checking the values, numeric values, nominal values are there. Then select the cluster again. Okay, any one of the algorithm. Let's consider the filter cluster. And here now you can select again one of the class for clustering evaluation. Again we are selecting the last one. Fine. And start again. So this algorithm has given some output like classes to cluster evaluation. That is okay. 14 instances, 5 attributes are there. And according to this one, cluster set cluster 1 and 0 has been generated. So rainy, if rainy season is there, so 75, 80 values. According to that, the cluster first is giving the false outcome, and this cluster 1 is giving the true outcome. Okay, so the final cluster centroid you can see here, similar to the k-means clustering, full data with respect to temperature, humidity, and YD, and along with the outlook. And you can see the cluster 0 and 1, which is if humidity is more in a sunny season and temperature is more, then outcome is false. That means don't go outside. Likewise, and other is like overcast. If values are less than the temperature, and in sunny, the values about temperature and humidity are less as compared to the sunny. So overcast values for temperature is less again, that is 69.77. So that is true. Means you can go. So clustered instances are only two because here we have not selected anything. Okay. So simple k-means clustering algorithm is automatically given to this algorithm, that is filtered output. Okay, so here filter, all filter is by default selected, so we have not changed anything. So only two clusters have been selected here uh, as, as compared with respect to the 14 instances. So first 0 is 9. Okay, means first this particular first cluster with respect to sunny, right? So that means the values are more for this sunny, and values are less for the overcast. Okay, that means you can go. So less values, that means true, and here highest values, that means false. That means it is clearly saying that attribute for class attribute play, how many are saying yes? 9 are saying yes. And how many are saying no? 5 are saying no. But that is true. So cluster 1 is yes, cluster 0 is yes, 1 is no. But see, the output is giving 42% incorrect answer. Why? Because normally uh, the value of overcast is true here, and still it is saying that no. That is why the incorrect instances are more here. By default, the algorithm has taken the two clusters. We have not set anything here. Fine. And so that is incorrect because the value of this first overcast is true, and here it is a false. Fine. That is why the more values are considered for the sunny, for first instance, for first cluster, and then for the second, at values are 5, but the accuracy is less. So likewise, we can select the cluster algorithms, and we can use it. Then coming toward the association rule. Association rule, for this purpose, we can use the nominal data, because association rule works with the nominal data. Okay, so remember that association rules related to the related associations we can make through the nominal data only, not a number data. So rules can be applied on the nominal data sets. So just click on the nominal data. Okay, associate. So here major three algorithms are there: a priori associate algorithm, filtered associator. So this class implementing and a priori type algorithm. So iteratively it reduces the minimum support, right? And then it finds the required number of rules with the given minimum confidence. Okay, so I'm just selecting this algorithm. Before starting it, Just open the settings through this option. Here, just click on a priori. We will get one window. Then here, minimum metric, that value is important. Keep 0.4, minimum 0.4, and rest of the things keep as it is. Click OK. Start it. Now see here, there is no evaluator for associator rule. And one more point is important here, that how many rules, association rules we want to generate. How many rules we want to generate? So those number of rules we can mention here. Okay, how many rules we want? According to that, we can just check it, and we can have this particular output. So by default number is a 10 for number of rules. So that is why just selecting as it is, and accordingly see the best 10 rules have been generated by the algorithm. Okay, so same instances with the attributes we have selected here. The rule is applied of a priori algorithm. So minimum support is 0.3 for 4 instances. Okay, and number of cycles are performed, that is 14. And you can see here generated sets of large item sets. So 12, 9, and 1. These three item sets have been generated, L1, L2, L3, right? So, and again, you can see best 10 rules have been given. Okay, so outlook is equal to overcast. If it is 4, then go to the go for the playing. Yes, so that is 4. So first rule, temperature is cool, value 4, humidity is normal, then 4 again. The humidity is equal to normal, windy is equal to false, 4, then play, yes. So likewise, rules can be generated as per the data. So association between the different classes, okay? Association between different uh, instances can be obtained through this one, okay, and then we can get the output. Fine. So just try this one, try these models, and then we can go for the other one. Just try it. If you have question till time, you can just put into the question answering section.
Sir,
Hi, yes.
sir, can you send the data set for practice?
Uh, which dataset? By default, datasets are there in the system, right? So WEKA is giving the by default datasets. So those can be used.
Sir, I don't have, sir,
Have you
in my
installed the
system.
WEKA?
Yes, sir.
Okay, so where it is might be WEKA is there in your C drive. Okay, so search for the WEKA
Hmm.
folder under the C drive. There you will get
Okay.
the option of a data. First of all, search for the WEKA in a C drive. Under WEKA folder, again you will get the data folder, and in that data
Okay,
you
sir.
will get the data sets.
Okay. Sir, one more question, sir.
Hmm?
Uh, are you arrange the any internship for data mining?
I will
From
ask to the organizer. Okay,
hmm.
might be they will organize some internships with respect to the data mining.
Hmm. Okay. Thank you, sir.
Due to some technical reasons, I'm feeling that the today's session was not little bit good as compared to the earlier ones. So today we will not send you any assignment because the contents are not perfectly delivered today. So the today's part we will cover in the tomorrow's session with the case studies. Fine.
Fine, sir. Don't worry, sir.
In the question answering section, I am putting the attendance for the today's session. Is there any question on the today's demonstration? Is there any question? Is there any question? So I have given the attendance in the chat box. So today's part we will cover in tomorrow's session. Don't worry about it because the session was
Yes.
not up to the mark, and initially we felt some technical issues. So the teams were logged out again and again, and the content was not delivered as per the expectation. So tomorrow, on the same time or before the time, we will start the session to cover the today's practical theory, and then afterwards. we will go for the case study. Okay, and practical, some practical sessions. So if no question, we will stop today.
No, sir. Yeah.
Okay. If no question, then we will stop today here. And today's session will be delivered tomorrow again.
Yes, sir.
So Robin sir is asking that can we apply the SVM algorithm? Yes, yes, we can apply the SVM algorithm. So I will show you everything tomorrow, because tomorrow will be the case study. So in the case study, all type of algorithms, important algorithms with the sample data set. The other data set which are not included in the WEKA will be taken, and then we will get some output through those data sets with the all important algorithms. Fine. Today assignment will not be given. So I'm ending the meeting for the today's session. Okay. So thank you all for your uh, patiently listening and cooperation. Yeah. Thank you, Doctor Sir. Tomorrow might be we'll start with one extra hour. So we will start at 7 p.m. Okay, so ending the meeting. Thank you so much for your patience and for listening everything. Thank you.